Welcome, Hornets, and thank you for joining me today. Today we're going to be taking a look at DeMoivre's theorem. DeMoivre's theorem says that we can take a root z to a power of n, which would be written as a complex number as r cis theta to the nth power, would actually be r to the nth power cis of the product n times theta. And this can work whether we're working with the complex numbers or working with fractional roots such as the square root, cubed roots, or whether we are working with powers such as 3 or -4 or 6 or whatever power we might want. Let's take an example. Let's go ahead and look at 1 plus I root 3 to the 4th power. Now ideally, when we look at this, we would not want to multiply this out and just FOIL it 4 times. It's just not going to be a fun thing for us to do. So instead, we're going to convert it into a cis form. So we're going to find r, which is going to be the square root of 1 plus 3. And that's going to give me the square root of 4, which equals 2. And then I'm going to look at my theta. And the theta is the arctangent of root 3. And we know that the arctangent of root 3 is going to be a 60-degree angle in degrees, or it could potentially be pi over 3 if we were working with radians. Now, because of that, we're going to apply our formula. We're going to say, well, I have 2 cis 60 degrees. And I want to take this to the 4th power. So I'm going to do 2 to the 4th power cis of 4 times 60 degrees. This will give me 2 to the 4th power is 16 cis, and I now have 240 degrees. This would be my answer in polar form. In order to find it as a rectangular form, I would once again then do 16 cosine of 240 degrees, and then I would have plus 16 sine 240 degrees, quantity times I. And using my calculator, or just recognizing that I have the cosine of 240, which is -1/2, and I have plus 16 times -root 3 over 2 times I. This gives me -8, and I have minus 8 root 3I. This would be my rectangular form, and just be aware that oftentimes we do want to move the I in between the radical and the constant. This is so that we don't accidentally think that that I is inside of the radical. All right, so just be aware I move that around a little bit, and it's not to frustrate you. It is to make sure that we can recognize that it is an imaginary number. So just be aware. Oftentimes we are given information, and we don't want to do it a long way. Instead, we quickly convert it into our cis form, and then we take the 4th power of the modulus, and we multiply our argument by the power. We then often will be asked to convert it back into rectangular form. However, if they don't, we can leave it in cis form. Let's go ahead and take a look at another example. This time, let's go ahead and take the, I don't know. Let's do I'm just looking through a textbook that I have here, and I'm going to do 5 cosine 30 degrees plus 5I sine 30 degrees, and I'm going to take it to the 3rd power. Now, in order to do this, I'm just going to go ahead and I'm going to multiply. So I have 5 to the 3rd power cis 3 times 30 degrees. This gives me 125 cis 90 degrees, or 125 cosine of 90 degrees plus 125 sine of 90 degrees I. Now we know that the cosine of 90 degrees is 0, so 125 times 90 is 0, times the cosine of 90 is 0. And then we have plus 1 which we get from the sine of 90 degrees times I. This gives me my answer, 0 plus 125I. You notice that's a lot faster to do than it would be if I were to convert it into the rectangular form and then work with the foiling method. Once again, not the most pleasant to work with. Now, DeMoivre's theorem also works with complex numbers. So, for example, let's say I wanted to find the cube root. So let's take 5 cis 30 degrees, and we're going to take it to the cubed root, which is a 1/3 power. That gives me the cubed root of 5 cis 10 degrees. Notice how easy that was. Once again, a heck of a lot easier. Now, in order for us to figure it out in rectangular form, we would then have to multiply it and find out what the fifth root or the third root, cubed root of 5 is. And then we would multiply it by the cosine of 10 degrees, and then we would add the cubed root of 5 times the sine of 10 degrees and put I behind it. Alrighty, so this is how we would find our powers of complex numbers in polar form, or if we wanted to find higher powers of rectangular form, we would want to convert it first into our cis form and then apply DeMoivre's theorem. Alrighty, I hope this was helpful. If it was, please remember to click like. If not, please give me suggestions and I will be more than happy to redo the video so that it is a better video and more useful to you. Thank you very much. Please be safe, be kind to each other, and I will see you soon. Bye-bye now. Cheers.